Hello, class. Thank God I got it's the browsers is working right now. So this is the video for section 7.2. Now remember in chapter 7 we're talking about decimals or rational numbers with the decimals and operations, and we have repeating decimals and non-repeating decimals. Okay, we talked about terminating decimals in section 7.1, and so here is the operations of decimals. That is addition, subtraction, multiplication, and then division in section 7.2. Okay, so these are learning objectives. We'll be able to use a concrete model or drawings or strategies that can be used to develop efficient algorithms for decimal operations, addition, subtraction, multiplication, and division. And then strategies for decimal mental computations and some estimations, right? So from the fifth grade, students should be able to add, subtract, multiply, or divide decimals to the hundreds. They should be also to use the concrete models and then some drawings and strategies to be able to find uh, add the operations based on what the place values that we talked about. Okay, so let's start with addition and subtraction of what decimals. Okay, we are given the problem 2.16 plus 1.73. Okay, using the base 10 blocks. Okay, now as I told you, when you're given any decimal, you have to ask yourself, what does 1 unit, okay, represent? Or 1 unit equals what? Now, if I look at these two, the highest decimal places is 2. So they are in what? In hundreds. So that means that where 1 unit will represent what? 1 flat, or is equal to what? 1 flat. Now, if you know 1 flat, that means that 1 long, okay, what's the value of 1 long? That would be 1/10. What's the value of 1 cube? Okay, 1 cube, that would be what? 1/100th. Okay, so if you have 2.16, we're going to represent what? 2 flats, okay, 1 long, and then 6 was of the cubes. Okay, that's what we see there. That's why we have this is 2, that is 1 of 1/10, and then 1 long, and then 6 of the cubes, giving us 2.16. And then the other one, 1.73 will represent what? 1 flat, okay, 1 flat and 7 longs, and then what? 3 of the cubes. So if you add this, how many flats do we have? 2 plus that, okay, 2 plus 1 is what? Is 3 flats, and then 1 plus 7 longs will give us what? 8 longs, but we write it as what? 8/10. And then you have for 6, okay, 6 of the cubes plus 3 of the cubes, giving us what? 9 of the cubes, which is what? 9/100th. Okay, so if you have this, this will be 3 longs flats plus 8 longs plus 9 flats, giving us what? 3.889. So that would be your answer. Okay, that will be our answer. Now, another way we can also add fractions using the 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 decimal grades. Now, again, we have 2. For the part A, we have 0.25 plus 0.31, and then 0.32 minus what? 0.17. Okay. Now, if I want to just go back a little bit, let's go back to the previous example. If I were to subtract this, all right, it is be easy to subtract 3 cubes from 6 of them, but you cannot subtract 7 from what? One long, 7 longs from 1 long. So if you were to subtract, then after representing, if you subtract, you have to borrow from what? The 1 flat, which is 10, making that what? 11. Then you can subtract what? 8 from that, that would be 4. All right. So if you do 2.16 minus 1.73, all right, as we can using the representations, this will be 3, that will be 4, and that will be just 0. Okay, so if you subtract these two, you get what? 0.43. Now let's go to the second example. If you have 0.25 and then 0.31, if you are adding them, notice that they're both in what, 2 decimal places, so they are in 100s. So we can use what, the 10 by what, 10 grid to represent that. Okay, so 10 by the 10 grid, meaning you have for 25, that is 25 hundredths. So you have, we count what, 25, you shade 25 of them, and you shade 31, and you add all together, that will give you 50 what, 56. And so 0.25 plus 0.31 will give us 0.56. Because if you shade all these and add all the shaded portion, that gives you that. On the other hand, if you are subtracting, that is 0.32 minus 0.17. Okay, now if you first you present the what, the 32, which is what, 32 hundredths. Okay, which is 32 hundredths. All right, so you have 32 hundredths. Then we are subtracting what, taking away 17 of them. Okay, so if you take away 17, that gives you this portion. Okay, if you take away 17, then you are left with this part. So you're going to count that, and that's just what, that is just 15, because you have 10 plus what, plus that. And when you subtract, you get remaining what, remaining 15 of them. All right, therefore, for the part B, 0.32 minus 0.17 is equal to 0.15. Okay. All right, let's go to the next page. Multiplying decimals. Multiplying decimals. Now, if you remember, if you want to multiply, say 3 by what, by 4, okay, if you are using the area model or the rectangular model, remember we're going to have how many columns of that? This is just a quick review. There will be what, 4 columns. There'll be 4 columns, right? And then how many rows? There'll be 3 rows. Okay, so this means that 3 times 4 is what, is 12, because there will be 12 of this. So the answer of this is what, is 12. Okay, similarly, we're going to do the same, only that here is a fraction, or the decimal is a fraction. Okay, so this is a problem. So use the area model. As a carpenter cut 2 shelves with the dimensions given below. Show how to use a model to find the area of each shelf. Okay, so we have shelf 1 and then the shelf 2. Okay, the first one, this is the same as 0.3, okay, times 0.5. Okay, so this is to represent the number of columns, and that is what, the rows. Okay, the shaded portion. Well, again, for both of them, we are using 10 by 10 grid. Okay, 10 by 10 grid. All right, so if I have 10 by 3, this is that's the 0.3 times that. Okay, then how many columns? If you have 10, you have 50. So you shade what, 5 of the columns, so that's 50. Okay, so this is what, 0.5. And then you are shading the row, that will be so 0.3, that is what, 3 of the rows. Now, which has the intersection will be what, this portion. Okay, and how many is that? That is, let's count, that is 5 times 3 is 15. Okay, so you have for 15 hundredth. 1500 is the same as what, 15 over 100, which is equal to, as a decimal will be what, 1.5. Okay, which is basically saying that 5 times what, 5 times 3, if you remember, if you use the standard algorithm, the standard algorithm, you have 0.5 times 0.3. Okay, what you do is that 5 times 3 is what, is 15. Okay, so you put what, 5 times 3 times 0 is 0, so that is 1. And then you have what, 0 times 5 is what, 0, right? And 0 times 0 is 0. So you get what, 5, 1. Okay, and you get what? 0. How many decimal places? The number of that is one from the one factor and the one from that are 2 decimal places. So this goes to be what? To be equal to 0.15. Okay. The second shelf, we have 0.5 times 1.5 by 10 by 10. Okay, this 1.5, that is what you have, one 10 by 10 grid and then another one. That's what we have double. But you have what? One, so you're shading the whole, that's a one hole, and then a half of the other one. And again, this is the number of rows, there are 5 of them. Okay, now when you look at this, if you count them, you have 1, 2, 3, 4, 5 times what? Times 15. 1 times 15 is what? 75. So this is equal to what? 75 for the hundreds. Okay, which is the same as 0.75. Okay, so we can use the what? The grid if you have a very simple problems like this. All right, even if you have something like a 0.25 times 0.664. Okay, so you have 25 of them. Okay, that will be, you're saying that you have what, 25 of the rows in that form. So when it comes the area model, you can use that, but when the numbers are bigger, you got to be careful how you do that, because if you multiply this, you're going to have what in 10,000s, and the grid, you're going to have what 100 by 100. Okay, and that's why you got to be careful with that. All right, the third example is we're using partial products that we talked about. Now this partial product is the same as what the distributive property. Okay, this is the same as the distributive property. Okay, so take note of that. So here we have June walked 1.7 miles in an hour. If she walks at the same rate, how far will she walk in 1.5 hours? Okay, in 1.5 hours. Now, if as a product, okay, notice that we can write that as what? 1.5, because it's the rate for 1 hour. Okay, she walks 1.7 miles. So if you have 1.5 miles, you can, how many hours, how many miles is that? Okay, you can think of this as 1.5. So if you multiply that by, that is what? That should be about 30 if you add all of them. So let's see how we can get that. Okay, well, this is the same as saying 1.5 times 1.7. Okay, which is the same as what? 1 plus 0.5 times 1 plus 0.7. And so if we remember this area model that we did way back in chapter 3, okay, when we are multiplying whole numbers, all right? So the first one, 1.5, so that is, this is 1, and that is 0.5. And this is 1 plus, so that's how we write it. Okay, so then 1 times 1 is 1. 1 times 0.7 is also 0.7. And then 0.5 times 1 is 0.5. And 0.5 times what? 0.7. As we did, you could notice that this would be 5 times 7, which is 35, and there'll be 2 decimal places, as we have explained before. Okay, so that'll be 35 hundredths. Okay, now what would be the answer then? You're going to have what? 1 plus 0.7 plus 0.5 plus 0.335. Okay, now if you add this, it's the same as 0.85 plus 0.7 and then 1 plus that. So you can have 1.7 plus what? 0.85. Okay, and that will give us, this will give us 5 and then 5 what? 5.2. So the answer will be what? 2.55. Okay, let's see how we had this and then get 0.85. So the 0 you add this, you get is 15, that is 5, and then 1, that is 2. So that's why I got what 2.55. So it means that June, okay, walks 2.55 miles in what 1.5 hours. Okay, 1.5 hours. Okay, let's go to the next page. Now, talking about division of what? Decimals. Division of decimals. Okay, so here's an example. It says that what 0.54 divided by what? Divided by 3. Okay, so you have 0.54 divided by what? Divided by 3. Okay, now what does this do? This answer the question, how many 3's are in what? 0.54. How many 3's are in what? 54. So if we partition that, how many you get? Okay, so if I use the grid, as you can see, all right, 10 by 10, and then 54, that's 54 hundredths. And so I shade what 50 and then 54. Okay, this part is what 0.54. Okay, now we're going to partition it into what 3. So 3 people are going to share that. So we use different colors. All right, the colors don't see, but I have blue, there's a deep green and then light green. All right, or kind of yellowish color. Now, so I have, if I'm sharing, since I have what 5 of the what of the column shaded, so that is blue takes 1, green takes 1, that's 1 column. And so now we have 2 of the columns and then what? And then a 4. Okay, so then we can go 1, 2, 3, 4, 5, 6 for each of them. All right, so if you go 1, 2, 3, 4, 5, that's 24 divided by that is be what? That will be 8. So you have the deep green, you have 6 plus the 2, that is 8. The light green, you have what? 4, you have 4, that is what? That is also an 8. And then the the blue, you have what? You have 8 of them. Okay, so what does it mean? You have what? The answer will be, that is 1. If you look at just each of the colors, you have, that is 10 plus 8. Dark green, 10 plus 8. Then the light green is what? 10 plus 8. So the answer to this would be what? 0. That would be what? 1800th. That'll be 1800ths. So that is equal to 0.18. Okay, now if I use the standard algorithm to calculate the same thing, okay, 3 into 0.54. Now, if you remember, 3 goes into 0 is not possible. So you put a 0 on top of the 0, and then the decimal must align. There's a point and the decimal point. They should align together. Okay. And then 3 in goes to 5. How many times? That is 1. 1 times 3 is what? Is 3. And you get what? 2. You drop down the what? The 4. 3 into 4 is what? Is 8. So 3 times that is 24. And that's 0. And therefore the answer is what? 0.18 or 1800th. Okay. And here is another example. We're going to use the bar model. It said Michelle purchases several bottles of water. Before tax is added, the total cost is $3.60, and the cost of each bottle is $1.20. How many bottles did she buy? How many bottles did she buy? Okay, in other words, how many groups of what? 1.2 are in what? 3.6. How many groups of 1.2 are in what? 3.6, which is basically saying that 3.60 divided by 1.2. Okay. Now, let's again use different colors, right? Let's do different colors. So we're going to partition this one 1.2, which is one whole number and then 2. So here you are represent the flat, if you want to call that as 1 by what, 1 by 10, where you have, this is one whole and then the 2 for the blue. And then the yellow, you have for 10 of them. So 1, 2, 3, that is 7 of them. So 8 plus what? Plus 4. This is what, that is 12. Okay, so that's a 12 of the columns. And then the other color you have for 6 and then what? And then 6. So that gives me the 3 point what? 3.6. So that is 1 whole, 2 and 3 and then a 6. That is a 3.6. And so how many of the 1.2? That is how many of the 12s in what? In 36, if you want to call it that way. Okay, and as we can see, there will be what? This is equal to 3. Okay, so there, it means that there are 12 1.2s in what? 3.6. Okay, so the answer, how many bottles did she what? Did she buy? That would be just 3 what? 3 bottles. Okay, now we can do the same thing using the standard algorithm. Okay, so if you have okay, I will just show you, because we have the next example explain that. So we have for 1.2 okay into 3.1.6. Okay, usually what we do is that we move the decimal. Is the standard algorithm. Okay, that's the standard. Okay, we move the decimal one place so that the divisor becomes a whole number. Okay, becomes a whole number. All right, let's demonstrate that in the following 2 examples. Okay, we have 13.169 divided by 0.13. So you have a 1.13 into 13.69. Okay, the first thing is that we want to make the divisor a whole number. So we move the decimal, how many places? 2. And then we move also this decimal 2 places. Okay, so then this becomes, okay, 13 into what? 1369. Sorry, 116 and 9. Okay, 1316.9. Okay, 13 into 13, how many times? That is 1. So you get 13. If you subtract, you get 0. Drop the 1. 13 into 1 is not. So we put it, it is 0. Okay, and then we add the what? We add the 16. The 6, sorry. You drop down the 6. So 13 into 16, that is what? That is 1. All right, and there's a decimal. So you put a decimal there as well. So this is 13. When you subtract, you get what? 3. And you drop the what? The 9. Okay, and then 13 into 39 is what? Is 3. Okay, so that gives you 39. So 39, and the answer is what? Is equal to that. So here your answer is 101.3. That is how many 1300s in 13 and 169 thousandths. Okay. All right. Let's look at another example. You get 9 divided by, so here you have a whole number, okay, divided by what? A decimal. The first one, you have a decimal divided by a decimal. Okay, so this will be 9 divided by 0.75. All right, now again, we want to make the divisor a whole number. So this is 0.0. So you add what? If you move it the 2 places, that's going to be what? 900. So then we're going to see this as what? 75 into what? 900. Okay, now 75 into 90, That is what? That is 1. You get 75. You subtract, and that gives you what? 15. And then drop the what? The 0. So make it, it's like the decimal you are considering as dividing what? Whole numbers. Okay. Now 75 into 150 is what? Is 2. So that is 150. You subtract, you get 0. All right. So for the answer, 9 divided by 0.75 is equal to what? Is equal to 12. Okay. All right. Now, let's go to the next one. The next page, we're going to look at some mental computations. Some mental computations. All right. Some mental computations. Now, all these strategies that we learned before, we don't forget them. Okay. When we did for the whole numbers, all the strategies, breaking and bridging, find the compatible numbers, and so on and so forth. Yes, you don't get rid of them. Okay, so you are computing this mentally. You have 1.5 plus 3.7 plus 4.48. Okay, so in your mind, you are looking at, if I have 1.5 and then I'm adding 3.7, maybe I can what? Add, break the 3.7 and make it what? 3 plus what? 0.7, and add the 3 to 1.5, because if I add 3 to 1.5, that would just be what? 4.5. So you are breaking this down. Okay, you are breaking this down. You are doing this. This is 4.5. Okay, plus 0.7, then plus 4.48. So you are thinking, okay, 1.5 plus what? Plus 3 is equal to the 4.5. So this is what we are thinking about that. That's in your mentally. Then if you look at the results there, what else can I do? Now let me add what? 1.7 to the 4.5. So if you add this, that gives you 5.2, because 0.5 plus 7 is what? Is 12. Then the 1, that gives you 5.2. Okay, so what we have here is 5.2 plus what? 4.48. Okay, so again, you are thinking 4.5 plus 0.7. You are breaking and bridging. So you break up the what? 3.7, and then you bridge it together to the results. Well, and then if you repeat that same, can the whole number part plus this will be 9.2 plus what? 0.48. Okay, and then finally, you are going to have what? 9.68 as your final answer. Okay, so you break up the whole number and then the what? The integer part, or sorry, the decimal part. Or sometimes it's if it's easier, I could have done this. I have 1.5, and if I add 0.5 to the 1.5, I know I'm going to get 2. So I could have done this 1.5. Okay, then I have 0.5 plus 3 point what? 3.2. Then I know that this will be what? This will be 2 plus 3.2, and that gives me 5.2. So you can approach it in whichever way. Once you break up one of the what? One of the addends, yeah, it should be able to do that. So that's one strategy, breaking and bridging, which we have talked about a while ago. Now, the second strategy is what? Compatible numbers. Okay, so you have compatible numbers. Let me write this addition vertically. So you have 7.91 plus 3.85 plus 4.09, and then you have for 0.15. Okay, we are adding these together. Now, if I look at this carefully, compatible number, getting like a whole number or 100, if you remember. Now look at this, I have what? 0.85 and 0.15. Okay, now if I add these two numbers, I know the 0.85, 15, and 8 would be like 100 hundredths, all right, which is what point, which is 1. Okay, and then I can add it to the 3. So that will give me, this will give me 4.0. 4.00. Then look at the 0.09 and then the 1. If I add 0.09 to the 0.91, I know that also will give me 1. And again, the 1 plus 7 plus 4. Okay, so that will give me also what? You get 11 plus 1, that will give you 12. And therefore, we can add these two guys together. 12 plus 12.00 plus plus 4, that gives me 16.00. Okay, so what you are doing is that you're thinking 7.91, okay, plus 4.09. I know that is what? That is 12. So this is, you are thinking about doing this what? Mentally. And then here too, you have 3.85 plus 0.15. You are doing that also what? Mentally, you know that is equal to what? Equal to 4. And then you add them, you get 16. Okay. And then we also have making compatible numbers. Making compatible numbers. All right. Here you're making a compatible number. You are trying to get 100 or get a whole number. All right. So you have 9.27 plus 3.79. Now, if I'm making a compatible number, I look at these two numbers carefully and I realize, okay, if I look at the 9.775, I know if I can have 9.525, all right, and then I add this to 75, I know I'm going to get 1. And so what happened is that we're going to break this down into 9.25 plus 0.002. Okay, and then this also becomes 3.75 plus 0.004. Now look at it, because the reason why I did that is that, okay, I know that 0.25 plus 75 will be what? Will be 100. All right. So if you're in decimals, the 25 hundredths plus 75 hundredths will be just a whole number, 1.00. Okay. So that's why this is 1, and you have 9 plus 3 is what? Is 12 plus 1, that is equal to 13. So you have get 13, and then if you add this, you get 0.006. So the answer will be 13.006. Now, remember, these are all, you're doing this mentally, or like if you go to the grocery shop and you bought something, $9.27, and then $3, another thing, $3.79. You want to know the total and making sure that you have enough money to cover that. Yeah, you just do this mentally. Okay, 9.727. Okay, let me make it to a 25, and then 79. 75 plus 25 is 1. That's $1 plus the $9. That's $10, and I have $3. That is what? That's $13, and then you can add the remaining. Okay, so that is about making compatible numbers. And then let's look at one with what? With subtraction, balancing with decimals in what? In subtraction. Okay, if you remember when we did the whole number, subtracting whole numbers, we said that adding what? Equal addends, right? So that is exactly what we are going to balance this with there. So they have 4.63, and then we are subtracting 1.93. So we can do this, or we have 4.63. Okay, I'm going to add something to that. And the reason is, if I look at the subtrahend, okay, the minuend and subtrahend 1.93. If I add so 97, not 3. If I add 0.003, if I add 0.03, not 0.003, I know that is going to be a 1. And if you have 1 plus 1, that will be 2. So it will be easy. So I'm going to break that, add something to that, equal addend. So that is 1.97 plus 0.03. Okay, and then I add the same to the what? The minuend, 0.003. Okay, so the same problem, then that becomes, then the top becomes 4.66. Okay, and then I subtract what? 2.00. So it is easy to subtract this a whole number from a decimal, and this will be what? 2.66 as my answer. Okay, this works like what? Equal adding what? Equal addends. Okay, equal addends. And then you go to the last but not the least. Okay, if you are dividing balancing with decimals in what? In division. Okay, please make this is a 0.25, okay, not 0.2. That was a typo there. So in the notes, make sure you change that. It's 8 divided by 0.25. Okay, look at it, 0.25 and divided by what? Divided by 8. All right, balancing with decimals in division. Okay, I know if I multiply, if I have 25 cents, think of it like a money, 25 cents, I have 4 of them, 4 quarters is $1. All right, so and it's, if I'm dividing any number by 1, that is very easy, right? So mentally, so let's multiply this by 4. Okay, if you multiply this by 4, that becomes a certain value, which is 1. And then if you multiply this also by 4, that becomes what? 32. Okay, so now you have what? 32 divided by 1, and that is equal to what? 32. Okay, so the answer is what? You get 8 divided by 32. Sorry, 8 divided by 0.25 is equal to what? 30 what? 32. So how many quarters are in $8? That's the same as saying that's what? That's 32. Okay, similarly, if I had given you something like a 0.5, okay, into 3, all right, to get a 1, you multiply the 5 by 1, sorry, by 2, that gives me 1, and then this also by 2, that gives me 6. So then the problem becomes 1 goes into 6, and that is 6. In other words, how many halves are in what? In the whole, in 3? There are what? There are 6 of them. Okay, so that's how we do that. And then the last but not the least, okay, this we want to know is scientific what? Notations. Now, why scientific notations? Why should the kids need to know? Now, in the sciences and in engineering, okay, in the US and outside US, people use what? Scientific notation to represent very large numbers or very small what? Very small maybe units or numbers, okay, or decimals. So with large or small numbers in the form, we have a times 10 to the nth power, where your a is less than what? Is less than 10 but greater than or equal to what? 1, and n is an integer. Your n is an integer. So how do you write this as in what? As in a scientific notation? Okay, first the a, all right, the a must not be what? Must be less than, between 1, it must be greater than or equal to 1, but less than what? Less than 10. And so if my decimal point is here, this 0.0000. Now if I move it backwards, 1 2 3 4 5, I cannot put it and write it as a 37 pointer, because 37 is greater than what? Greater than 10. But my a cannot be. So I'm going to write this as what? A times 10 to some number. Okay, so we're going to be 1 2 3 4 5 6 7 and then 8. Okay, so this becomes 3.74. Don't round anything. 3.74 230,864, then times 10. 10 to what? What's be the power? Will be your n. Because you move it backwards 8 times, this will be raised to what? Raised to 8. Okay. So if I want to write it back, I move the decimal point forward 8 places. Okay. Now over here too, we move the decimal here and go to 1 to the right. 1, 2, 3, 4, 5. It must be between the 4 and 5. So this is written as what? 4.547, then times 10. And because you move the decimal to the right, the exponent is negative. Negative of how many places that you moved it. That is what? To the 5th power. Okay, so each of these is in what? Scientific what? Notation. Okay. And finally, when it comes to measurement, if I give you a measuring tape and I ask you to measure the edge of a table, the size of a table, and to your students, guess what? They will make what? Different. They will know all of them are not going to get exact what? Exact measurement. There will be slight differences in what? In decimals. Okay. And because of that, we have what we call the round of what? Errors. Now the differences happens because of rounding. Okay. And we want to make sure that what is the greatest possible error that it occur in any measurements. Okay. So we abbreviated that as what? GPE. That is the greatest possible error. Now, please, these are in measurement. Let's call them, this is 74.56 centimeters, and that is also centimeters. I forgot the units. Okay, so for the A, let's say that this is what? 7.456 was centimeters. 6 centimeters. Okay. All right. Now, what is the measuring what? Error. Okay. Now, this is what in a thousands. Okay. It says that the greatest measurement is defined as 1/2 of the measuring what? Unit. Okay. So here, the measuring unit is in thousands. Okay. Is to the nearest, okay, thousands. Okay, so therefore your GPE is equal to 1/2 of 0.001. Okay, the thousands to the nearest thousands is what is that. And so if you divide this by 2, you get 0.00005. Okay, centimeters. So that is your greatest what? Possible what? Error. And for part B, we have for 74.56 centimeters. Okay, the measuring unit is what? To the nearest what? If you look at it, that's the 2 decimal places to the nearest hundredths. All right. So then your GPE is equal to 1/2 of 0.001. Okay, because of what? It's in that what? Measuring that hundredths. And this is equal to 0.005. Okay, centimeters. All right, so that is the end of section 7.2, and I believe this is helpful. Let me know if you have any questions, and I'll try and post the what do you call it, 7.3 later. All right, thank you. Bye-bye.